Picture a wall of steel the length of nearly 4 football fields, floating. It stretches 399 meters from bow to stern, spans 61 meters across, and weighs more than most skyscrapers. On May 8, 2026, this massive structure slid out of a shipyard in Nantong, China, turned its bow toward open water, and quietly rewrote the rules of global power. It is called the OOCL Wisdom. It is an ultra-large container ship capable of carrying 24,168 steel shipping containers in a single voyage, and it does all of this while running on a cutting-edge fuel meant to be nearly carbon-free. It is by almost every metric the largest and most advanced ship of its kind ever built. But the real reason this ship should stop you cold has absolutely nothing to do with global trade, environmental engineering, or the logistics of moving consumer goods. The real reason is a single, uncomfortable fact that the United States military has been quietly studying. The United States could not build the ship right now if it wanted to. Not in a year, not in 5, not in 10. And the industrial capability required to forge, assemble, and launch a vessel of this scale simply no longer exists inside the borders of the world's leading superpower. And what that single realization means for the next 2 decades is something the U.S. Navy's own intelligence analysts have been splashing across classified briefing slides in Washington, because by the time you look past the sheer scale of this vessel, you begin to see a much larger, much more urgent puzzle. You begin to understand how China didn't just build this ship, but why they are building 12 of them at once in a single $3 billion order. You begin to see why an ordinary commercial cargo carrier is actually the clearest, most undeniable picture anyone has of who will ultimately control the world's oceans, to truly understand why this matters. You first have to grasp the sheer engineering paradox floating beneath the deck. An ultra-large container ship is one of the biggest moving objects human beings have ever constructed. If you took all the containers stacked on the OOCL Wisdom and lined them up end to end on a highway, they would stretch for more than 90 miles. If you stood the ship upright on its stern, it would dwarf the tallest towers in almost any skyline on Earth. Yet, for maritime engineers, building something that big was never the true obstacle. The real barrier, the one that kept the entire shipping industry stuck in the past, was the fuel. Almost every massive vessel on the ocean today runs on heavy marine fuel oil. It is essentially the sludge left over at the bottom of the oil refining process, thick, toxic, and incredibly dirty. For years, global logistics companies have desperately tried to transition their fleets to green methanol, a fuel that burns so cleanly it produces almost no soot or sulfur, but methanol comes with a massive catch. It holds only about 1/3 of the energy density of conventional fuel. To use it, a ship doesn't just need a bigger tank, it needs an absolute monster of a tank, alongside a highly complex dual-fuel engine that can switch between fuels instantly without losing a single knot of speed. Nobody had ever managed to scale this technology to the absolute limits of naval architecture. Until now, the engineers at the Nantong Yard outfitted the Wisdom with the largest methanol dual-fuel engine, auxiliary system, and boiler ever engineered. To feed this massive power plant, they carved out a methanol fuel tank holding 14,300 cubic meters of liquid. That single design choice gives this colossus a continuous range of 15,000 nautical miles on green fuel alone. That is enough distance to sail from the coast of East Asia all the way to the far side of Europe without stopping to refuel a single time. When she is running on methanol, her sulfur emissions drop to zero, her nitrogen oxides cut in half, and her carbon footprint shrinks by 150,000 tons a year. That is the equivalent of permanently erasing the emissions of 30,000 passenger cars, accomplished by a single ship. To make the economics even more devastating for competitors, she carries roughly 7,000 more containers per trip than the largest vessels operated by Europe's biggest shipping lines. It is a triumph of modern engineering, a blueprint that completely redefines what a commercial vessel can be. But here is the turn in the story where the math stops making sense, and where the focus shifts from a single engineering marvel to something far more systemic. China did not just build the OOCL Wisdom as a proof of concept. They are currently stamping them out in mass production. The ship itself, as it turns out, is just the small story. The real story belongs to the place that built it, and the staggering, lopsided reality of global manufacturing that it reveals. The shipyard in Nantong is not a secret military base or a hidden government facility. It is a standard commercial shipyard, one of dozens dotting the Chinese coastline. Yet the speed and efficiency with which this yard can manufacture a vessel this complex comes down to a set of industrial metrics that are genuinely difficult to believe. To understand how we arrived at this moment, you have to look at the historical mirror. Decades ago, during the height of the Second World War, American shipyards were the undisputed wonders of the industrial world. They outbuilt the entire planet combined, launching cargo ships faster than Axis submarines could ever hope to sink them. Shipbuilding was an American economic superpower, the foundation of its global dominance. But, over the closing decades of the 20th century, the West gradually walked away from heavy industrial manufacturing. Now, look at where that power landed. China accounts for more than half of all commercial shipbuilding on the planet, capturing over 60% of every single new ship order placed worldwide. To put that in perspective, in a single recent calendar year, Chinese yards constructed and launched more than 1,000 large commercial vessels. In that exact same year, across the entire United States, American shipyards managed to build just 8, not 800, 8. In fact, a single Chinese state-owned shipbuilding enterprise now produces more for commercial shipping tonnage in 12 months than the entire United States manufacturing base has produced since the end of World War II. For every single commercial vessel America launches into the water, China launches more than 100. The American share of the global commercial shipbuilding market has withered to roughly 0.1%. One ship out of every 1,000. And this massive industrial vacuum isn't just confined to the hulls of the ships themselves. If you walk onto the docks of any major American port, you will see giant ship-to-shore cranes unloading the goods that keep the domestic economy alive. Roughly 80% of those cranes are manufactured in China. The steel boxes stacked on the decks, the very containers that define modern commerce, are 96% Chinese-made. The United States' production of both cranes and containers is effectively zero. The nation that originally invented mass production shipbuilding now relies entirely on the infrastructure, the tools, and the cargo boxes supplied by the nation that replaced it. Meanwhile, the few remaining American yards operate on aging infrastructure, struggling with a critical deficit of over 100,000 skilled maritime workers. This isn't a standard economic competition. It is an entirely different reality. And this is the precise point where the conversation shifts from global trade directly into the war rooms of the Pentagon. Because this 1,000 to 8 manufacturing gap was never truly about cargo, consumer electronics, or shipping routes. It is about a fundamental vulnerability that the Western world has no immediate way to fix. Here is the perspective shift that turns an eco-friendly container ship into an urgent national security crisis. The exact same shipyards that mass-produce those 1,000 commercial vessels a year, utilizing the exact same welders, the exact same specialized steel supply chains, the same automated cranes, and the identical dry docks, are the exact same yards tasked with building China's rapidly expanding navy. A commercial container ship and a high-tech guided missile warship roll out of the very same industrial ecosystem. This means the unparalleled manufacturing capacity that produced the OOCL. Wisdom is the exact same capacity currently producing advanced naval destroyers, amphibious assault ships, and nuclear submarines. The U.S. Navy has done the grim math on what this industrial imbalance actually means in a prolonged geopolitical crisis. The Navy's own Office of Naval Intelligence estimates that China's shipyards now possess the raw industrial capacity to outbuild the United States on warships and submarines by a factor of more than 200 to 1. China's Navy has already surpassed America's to become the largest fleet in the world by pure ship count, and their technological sophistication is catching up with terrifying speed, evidenced by the recent launch of their newest aircraft carrier. Outfitted with advanced electromagnetic catapults, a level of technology the United States has only recently managed to field after years of development delays. In any extended maritime conflict between major powers, history shows that the decisive factor is rarely the outcome of the very first battle. The ultimate victor is almost always the side that can rapidly replace its losses, repairing damaged vessels and launching new ones while the conflict rages. On one side of the ocean sits a nation that can manufacture 1,000 massive ships a year. On the other sits a nation that struggles to build 8. Letters in Washington see this strategic trap with perfect clarity. The U.S. government recently launched an aggressive push, signing executive orders designed to revitalize domestic maritime industries, proposing hefty fees on foreign-built ships docking at domestic ports, and threatening massive 100% tariffs on Chinese-made port cranes. It was the most confrontational economic stance taken in a generation, yet within mere months, as the complex realities of global trade reasserted themselves, those very port fees were quietly suspended as part of a broader, fragile trade truce. The moment the counterpunch was thrown, the economic system buckled under its own dependencies, forcing a pause. As one prominent naval defense analyst flatly summarized the situation, there is simply no near-term path to bending these production curves back in the West's favor. Ultimately, none of this was ever truly about the shipping containers. The OOCL wisdom is a physical receipt of a tectonic shift in global power that took place while the rest of the world was looking somewhere else. The ship is real, its specifications are documented, and the industrial chasm is openly admitted in the highest levels of military intelligence. Which brings us to the ultimate unresolved paradox of this entire crisis. If a single nation now controls the yards that build the ships, the factories that forge the containers, and the technology that powers the next generation of clean energy fleets, they hold an undeniable stranglehold on global commerce. But warships are not container ships. They require specialized armor, highly sensitive radar arrays, complex weapon systems, and nuclear propulsion technology that cannot simply be stamped out like a steel cargo box. Or can they? To find out how deep this industrial dominance actually goes, we have to look inside the specific, classified design choices of China's newest naval vessels and look at the hidden features buried inside their commercial fleet that suggest these cargo ships were designed from day one to do a lot more than just carry boxes. To understand how a commercial shipyard can morph into a geopolitical juggernaut, you have to look past the steel hulls and dive directly into the engine room. This is where the engineering reality shatters the conventional view of manufacturing. Most people look at a warship and a container ship and see two entirely different species. One is a floating fortress bristling with missile silos, radar domes, and armor plate. The other is a glorified floating parking lot designed to carry consumer goods as cheaply as possible. They seem to share nothing but the water they float on. But that assumption is exactly how the West miscalculated the game. At the foundational level of naval architecture, the core mechanism of building any ship, whether it is a guided missile destroyer or the OOCL wisdom, comes down to three identical industrial pillars: modular block construction, precision metallurgy, and propulsion scaling. If you master those three at an unprecedented scale, the distinction between a commercial fleet and a combat fleet virtually disappears. Let us start with the core mechanism of how modern giants are actually put together. China did not achieve its massive shipbuilding lead by simply hiring more workers to weld steel plates together faster. They revolutionized a process known as mega-block modular construction. Think of it like building with ultimate-scale Lego bricks, but where each brick is the size of a 4-story apartment building and weighs several thousand tons. In a traditional shipyard, you would lay a keel at the bottom of a dry dock and slowly build the ship from the ground up, piece by piece, out in the open air. It is slow, highly vulnerable to weather delays, and severely limits how many people can work on the ship at one time, because everyone is fighting for space in the same hull. The Chinese megayard mechanism turns this approach completely on its head. Instead of building a ship in one piece, the yard splits the blueprints into massive, distinct modules. One workshop builds the entire bow section, another, miles away, constructs the midsection hull blocks. A third specialized facility assembles the entire multi-story superstructure, complete with the captain's bridge. Crucially, these blocks are not just empty steel shells. While they are still sitting upside down on a workshop floor, technicians go inside them to install the plumbing, run miles of fiber optic cabling, paint the interiors, and mount the auxiliary machinery. Once these massive blocks are fully prepared internally, they are rolled out to the main dry dock using specialized heavy transport vehicles. Giant gantry cranes lift these multi-thousand-ton segments into place with millimeter-level precision. At that point, the shipyard workers aren't building a ship anymore. They are simply fusing the blocks together. Now, consider the profound implication of this mechanism. If your industrial base is optimized to stamp out these massive, pre-outfitted structural blocks for a 400-meter container ship week after week, the transition to building a naval destroyer is not a technological leap. It is a mere change of the digital blueprint. The cranes don't care if the 3,000-ton block they are lifting is a cargo hold or a missile magazine. The welders don't care if the high-strength steel they are joining is meant to hold fuel or resist shrapnel. The entire heavy infrastructure is completely dual use. The commercial pipeline acts as a massive self-funding training ground that keeps the supply chains warm, the factories running 24 hours a day, and the workforce highly skilled. But the modular construction is only half the battle. The true heart of the OOCL Wisdom's secret is how it solves the massive energy crisis of alternative fuels, a mechanism that directly mirrors the challenges of advanced naval engineering. To run a ship of this size on green methanol, engineers had to solve a fluid dynamics and combustion puzzle that had never been tackled at this scale. Methanol is a liquid alcohol. Because it contains oxygen atoms within its chemical structure, it burns incredibly cleanly, leaving behind virtually no particulate matter. But that exact same chemical structure means it possesses a dramatically lower energy density than traditional bunker fuel. If you inject a gallon of methanol into an engine cylinder, you get only a fraction of the explosive punch that a gallon of heavy oil provides. To overcome this, the engine mechanism of the Wisdom has to be an absolute marvel of variable high-pressure injection. The ship's main power plant is a dual-fuel two-stroke engine that stands as tall as a house. Inside its massive cylinders, the engines must precisely manage two completely different liquids with entirely different ignition properties. When running in green mode, the system uses a method called the diesel principle, but with a twist. Because methanol doesn't ignite easily under compression alone, the engine first injects a tiny, microscopic mist of traditional pilot fuel into the hot, compressed air of the cylinder. This pilot fuel ignites instantly, acting like a giant chemical match. A fraction of a millisecond later, specialized high-pressure fuel valves blast a massive volume of methanol directly into that burning flame front. Because methanol requires a much higher volume of liquid to achieve the same horsepower, the fuel injectors must cycle at blinding speeds, pushing massive amounts of liquid under intense pressure without eroding the metal components. To prevent the corrosive alcohol from eating away at the fuel lines, the entire delivery system is jacketed in a double-walled safety mechanism, monitored by automated sensors that can detect a single drop of leakage instantly. This brings us to the ultimate hidden mechanism of the entire Chinese maritime strategy, one that should cause serious reflection in Western naval command centers. The transition to these massive, complex dual-fuel commercial engines isn't just about corporate sustainability or meeting international climate targets. It is an industrial masterclass in scaling high-end propulsion technology. The manufacturing tolerance required to build a high-pressure, dual-fuel system for a global container ship is virtually identical to the precision engineering needed to build the advanced propulsion systems of modern warships. By locking down the global market for green commercial ships, China has forced its domestic industry to master the most complex metallurgy, the most advanced automated fuel delivery systems, and the largest precision casting facilities on Earth. So, when a Western analyst looks at the OOCL Wisdom and sees an eco-friendly cargo carrier, they are missing the forest for the trees. What they are actually looking at is a mass production pipeline that has successfully solved the hardest problems in heavy manufacturing. The yard has mastered how to move massive weights, how to precision weld advanced alloys, and how to scale complex machinery under extreme constraints, which leads to an even more unsettling realization. If the mechanisms for building giant commercial ships and advanced warships are practically identical, then the line between a civilian merchant fleet and a military fleet begins to blur in ways the world hasn't seen since the Age of Sail. And that raises a dark, critical question that goes far beyond manufacturing metrics. If these commercial shipyards can turn out massive, standardized hulls at a rate of 1,000 per year, what happens if those hulls were never actually meant to stay purely commercial? What if the world's largest fleet of cargo ships contains a hidden structural design, a literal trapdoor built into the steel, that allows them to transform into something else entirely the moment a conflict begins? Now, to understand how we reached a point where an ordinary cargo vessel carries such terrifying strategic weight, you have to look at the massive industrial ecosystem that feeds these yards. This is not just a story about China building ships faster. It is a story about a coordinated, decades-long grand strategy that has effectively cornered the market on the global maritime supply chain. The West treated shipbuilding as a low-margin, legacy industry and let it slip away. China treated it as a foundational pillar of national sovereignty. Andaman partners, the mechanism of modular construction described earlier, only works if you have an unshakable grip on the raw materials and infrastructure beneath it. And this is where the lopsided reality of the global market truly begins to bite. Every single component required to build a vessel like the OOCL Wisdom, from the specialized high-tensile steel plates to the heavy-duty automated valves, is produced domestically within a tightly integrated supply chain. Chinese steel mills, heavily subsidized by the state, provide an endless, cheap supply of marine-grade metal directly to the waterfront. There are no shipping delays, no vulnerability to foreign supply shocks, and no waiting on overseas contractors. The maritime executive, but the strategic calculation goes much deeper than just dominating commercial trade. In the background, Beijing has quietly erected a legal and structural bridge between its commercial fleet and its military apparatus. This is a framework known as military-civil fusion, and it means that the line between a civilian merchant ship and a frontline military asset is deliberately being erased. The Economic Times show one, in fact. The Chinese government enacted strict technical standards requiring 5 specific categories of civilian vessels, including container ships, roll-on, roll-off car carriers, bulk cargo ships, to be built with explicit military modifications. This means that, as a ship like the Wisdom is being assembled in its modular blocks, the structural foundation is engineered from day one to allow for rapid emergency military mobilization during a wartime crisis. Popular Science, Yesho 1. This isn't just a theoretical concept on a government slide. We are seeing this reality play out right now in real time. In a series of massive maritime exercises, the People's Liberation Army has openly demonstrated how it intends to weaponize this commercial behemoth. Fresh intelligence imagery from early 2026 revealed that China has begun converting standard, mid-sized commercial cargo vessels into improvised military platforms. Aerospace Global News, by utilizing the exact modular nature of modern shipping, they have designed weapons systems that fit neatly inside standard intermodal ISO shipping containers. To the untrained eye, or to a satellite passing overhead, a ship looks like an innocent merchant vessel hauling consumer goods. But inside those standard steel boxes sit fully functional, vertically launched anti-ship cruise missiles, air defense systems, and theater-range strike platforms. A crew of just 4 operators can deploy a devastating missile volley from the deck of what appears to be a completely civilian ship. South China Morning Post-it gets even more radical. Recent technical reveals have shown commercial cargo vessels modified into makeshift drone and missile platforms, complete with modular electromagnetic catapult systems welded directly onto their decks. These improvised auxiliary ships are being field-tested to launch heavy, next-generation combat drones, effectively turning a cheap, mass-produced merchant vessel into a pocket aircraft carrier or an armed picket ship capable of providing area air defense. Aerospace Global News, when you connect these tactical modifications to the sheer volume of the Chinese merchant fleet, the strategic math becomes overwhelmingly lopsided. In a protracted conflict in the Indo-Pacific, the United States Navy would be forced to rely on a tiny, exquisite fleet of highly expensive, difficult-to-replace warships. If a billion-dollar American destroyer is damaged or sunk, the domestic industrial base requires years to replace a single hull. China, conversely, can draw upon a limitless reservoir of thousands of commercially funded, structurally reinforced cargo vessels, backed by a shipyard infrastructure that builds more in a single year than the United States has built in decades. This represents a complete rewrite of the traditional rules of naval warfare. For the last 80 years, the global oceans were governed by a simple rule. The nation with the most advanced, dedicated warships controlled the seas. But by fusing the endless cash flow of global commercial trade with direct military utility, China has built an industrial engine that converts economic dominance directly into naval supremacy. And they are building the rules of the 21st century ocean because they are the only ones who can physically build the fleet. Geopolitical monitor. Yet, as impressive and terrifying as this dual-use infrastructure is, we have still only scratched the surface of where this trajectory is headed. The transition to methanol engines and modular missile containers is merely the intermediate step in a much longer, far more ambitious industrial roadmap, because right now, inside the highly secure design bureaus of the state-owned Jiangnan shipyard, Marine engineers are putting the final touches on a blueprint that aims to leapfrog the entire global maritime establishment by half a century. They are moving past alternative chemical fuels entirely, designing a new class of ultra-large container ships powered by an advanced fourth-generation molten salt thorium nuclear reactor, a ship designed to sail the open ocean for 40 years straight without ever stopping to refuel a single time. CPG, click oil and gas, click petróleo y gas, and that brings us to the final most critical pivot of this entire geopolitical puzzle. If China successfully scales commercial nuclear propulsion before the rest of the world can even build its basic welding workforce, the strategic gap won't just widen, it will become permanent. But building a nuclear reactor that can survive the punishing environment of the open sea requires a level of technological mastery that goes far beyond raw steel production. It requires an entirely different class of engineering, and a hidden breakthrough that Western intelligence is only now beginning to uncover. To understand exactly where this race ends, you have to look past the modern horizon to that next radical leap in propulsion technology, the commercial nuclear cargo ship. In late 2023, China's state-owned Jiangmen shipyard shocked the maritime world at an industry expo by unveiling the first official design for a 24,000-container behemoth powered by a fourth-generation molten salt reactor. It is a ship designed to run on liquid thorium, operating under high temperatures and low pressures, eliminating the risk of a traditional nuclear meltdown. If a leak occurs, the fuel simply freezes solid, containing itself safely. For a commercial operator, it means an ultra-large vessel that can sail for its entire 15 to 20-year lifespan at sustained speeds of 25 knots without ever pulling into a port to refuel. It completely decouples global trade from the geopolitics of oil, gas, or even methanol supply chains. But for the Pentagon, the true panic over a commercial thorium reactor has nothing to do with green logistics. It comes down to the ultimate rule of maritime power. If you can scale a fourth-generation nuclear reactor to survive the grueling vibrations, corrosive salt air, and constant motion of a commercial cargo ship, you have just perfected the exact same power plant needed for next-generation nuclear-powered submarines, stealth destroyers, and supercarriers. Once again, the civilian economy pays for the military breakthrough. While Western defense contractors spend decades and billions of taxpayer dollars trying to custom engineer small modular reactors in a vacuum, China is using the global shipping market to subsidize, test, and mass produce the very heart of tomorrow's Navy. By the time the first nuclear container ship rolls out of a Chinese dry dock in the late 2020s or early 2030s, the underlying technology will have been refined across millions of nautical miles of commercial trade. This brings us all the way back to where we started, to that massive wall of steel, the OOCL Wisdom, sliding into the water at Nantong. When you look at her now, you realize she was never just a vessel built to move cheap electronics or sneakers across the ocean. She is a floating proof of concept. She is a loud, undeniable declaration that the industrial engine of the world has officially changed hands. For the better part of a century, the West comforted itself with a comfortable myth that even if it outsourced its factories, its clothing mills, and its basic assembly lines to Asia, it would always maintain a permanent monopoly on high-end, complex engineering. The belief was that the West would design the future, and everyone else would simply assemble it. But the OOCL Wisdom shatters that illusion entirely. You cannot design the future of the oceans if you no longer possess the physical capacity to weld it together. Innovation does not live in an isolated office building in Washington or Silicon Valley. It lives on the factory floor, in the dry docks, and inside the minds of the engineers who actually have to make 3,000-ton blocks of steel fit together with millimeter precision. The lopsided reality of the current era, where China launches more than 1,000 major commercial vessels a year, while the United States struggles to launch 8, is not a temporary market imbalance that can be fixed with a few tariffs, an executive order, or a new piece of trade legislation. You cannot rebuild an entire vanished industrial ecosystem or train a missing army of 100,000 master shipwrights overnight. It took decades of quiet neglect for the West to walk away from its maritime superpower, and it will take decades of painful, focused effort just to get back into the race. In the meantime, the global ocean continues to move to a new rhythm. The ships that carry 90% of all global trade are increasingly built by one nation, tracked by cranes made by that same nation, and packed into steel boxes stamped by that same nation. And the rules of the open water, from the environmental standards of green methanol to the tactical protocols of emergency naval mobilization, are being written by the people who own the physical infrastructure of the waterfront when the OOCL Wisdom Cross rests the horizon on her way to Europe. She carries a hidden truth welded directly into her hull. She reminds us that true geopolitical dominance isn't just measured by the number of active warships a country keeps on deployment, or the sophistication of the missiles tucked away in its arsenals. True dominance belongs to the nation that holds the keys to the shipyard. We tend to think of history as a series of sudden, dramatic explosions, a single decisive naval battle, a sudden declaration of war, or a dramatic political collapse. But the real shifts in human history are usually much quieter, built block by block, weld by weld, in ordinary coastal towns while the rest of the world is looking somewhere else. The race for the 21st century ocean wasn't lost in a clash of arms out at sea. It was lost day by day, vessel by vessel, on the empty, quiet slipways of a superpower that forgot how to build.